Hi guys, this is Sham,
Hi guys, this is Linus.
and we are going to talk about how to run Azure IoT and AI on Edge. So, as I said, my name is Ishan. I'm Cloud Solution Architect for Data and AI at Microsoft, and I'm also a mentor for a lot of people who are starting to learn cloud.
And my name is Linus Hammarstrand, and I'm an enterprise sales specialist specializing in data and AI on Azure, working for Microsoft. But I'm originally an archaeologist, and I'll get back to that later.
So we're going to talk about a bit about what intelligent cloud, intelligent edge is, and how IoT edge and AI edge come into the play. We are going to introduce something called Azure Stack. And then we're going to talk about a couple of scenarios where this is applicable and a couple of case studies. So what is intelligent edge? Well, intelligent edge is everything that you have as a device today. So this is how we can visualize modern cloud. So we have cloud processing in the middle, all the services and the um, services the cloud provides. And then at the edge, you have all the devices. So devices like your fitness bands, fitness trackers, smartphones, even bulbs, car, everything, that's edge devices. And these devices can help you gather data with help of a different type of sensors and so on. In a traditional solution, you will be gathering the data from your devices, as we have down here. So we have, like, for example, a fitness band. But then in a traditional solution, you will take that fitness band data and send it to a data center somewhere in the world. And then that data center will talk to a cloud when it needs to utilize more processing power, when the data center doesn't have the power. But if we go to a modern scenario, we will have our devices, the edge devices, like we still have this band here, and it will talk to the cloud by itself. So for instance, when you have like your Apple Watch or your Google, your either you're using Apple iOS or iPhone or Android. On Apple, you will have Apple Fit. On Google, you have Google Fit. They are actually connecting to your band and talking to a cloud at once. So that's more a cloud edge app scenario. And this scenario might not be possible for every single, or this solution might not be viable for every scenario. So we're going to talk through which and why. So what is intelligent edge? It can be any of the devices. It can be like we can define an edge as a building if we want, or your laptop, or your tablet, or your phone, or the manufacturing, the drones we use. HoloLens can be an edge device, or any type of sensor that is on ground, so to say. So intelligence as is together with the sensor and devices, and then where you get data, and then you use that data to get some real-time insights. And so that you don't have to wait to get the decisions, you need the critical decisions, like if there's alarm or if there's a life-threatening situation in a hospital, you don't want to be dependent on the latency of the cloud, because you might be somewhere out in a bad connecting area. So you don't want to wait the latency it takes for the information to go to the cloud, make the decision, send an alert. So if something like a hospital scenario, you might want to have a lot of some sort of processing power right there in the hospital.
Yeah,
But
another good example would be in a disaster zone, say an earthquake, natural disaster, major fire, or something like that, where you cut off and we really need to respond very quickly. You may not have the time to communicate, and IoT Edge could make a big difference here.
Exactly. So the whole solution actually flows from your sensors to the cloud. It's not like you have one solution for edge, one for cloud, and so on. It's a single solution which will stretch all over. And how we do it with Azure is we have Azure IoT Edge and Azure Services. but you have the same underlying security, the Active Directory, the management, and so on, which expands between the cloud and the edge, so that you can have, for example, a holistic security profile. So that just because these are two different data centers, or like Azure Stack can be in your car and you're connecting to Azure Cloud, so you still have the same security profile. Here's an example of how you can deploy an IoT solution uh, by using both cloud and edge. So we can develop our solution as containers. In this case, we are using Docker container, and we can push that container to a container registry. So in this case, we have developed a set of functions which we are pushing as a container to our ACR, Azure Container Registry. And then the edge device, it can be a Raspberry Pi, it can be anything which doesn't have that much compute power, can then download the latest version of this container whenever it is connected to the internet. That's the beauty of the edge device. It doesn't have to be always connected, only to get the updates and push the updates. And then it can gather the data, whatever the sensor is sending, create the insights with the functions we already deployed to it, and then send the insights and even raw data to IoT Hub in cloud whenever it can. So this is a more, so to say, disconnected scenario. And same thing if we are using something like AI or machine learning. We develop the solution as a container. We push that to container registry. In this case, we have image classifier and camera capture containers, and then we deploy these in our IoT edge device. Then the IoT will use a camera to capture the image, to classify the image, and then send the insights it has gathered from these to IoT Hub, so that it can be even more processed and handled in the cloud.
Yeah, and now there is a new service as well, Azure Persons, where you can bring the AI to the edge, and that comes with out-of-the-box cognitive services, for example, computer vision and so on. So you can really benefit from AI on the edge.
Precisely. So we have, like Microsoft have released a lot of containerized services, so that as Linus talked about computer vision. So it is containerized as a single container, so that you can deploy it in anywhere you can run Docker container. Then we get into Azure Stack. Uh, uh, to uh, to enable intelligent edge, Microsoft is offering something called Azure Stack. And Azure Stack does not only enables you to have intelligent edge, it can also enable you to have hybrid cloud. So it does two things. Hybrid cloud is when you have some services running on-prem, some on cloud, like Azure. Azure Stack also enables one to run some of the cloud services on-prem. So basically, in most cases, you can develop for the cloud and then deploy them on an edge on-prem if needed. And Azure Stack comes in three flavors. So we have Stack Edge and Stack Hub. They are more turnkey solutions. So you buy the hardware and software from Microsoft, you put it in, and it's ready to go. While HCI, High Compute, is more software based. So you have your own hardware and you install the software on it. And this is how basically a disconnected scenario would work. We will replace basically the public cloud with Azure Stack Hub. So you can run still the same capability you had with the public cloud you have with Stack Hub. While like Azure Stack Edge will need either hub or public cloud to function. Let's talk about a little scenario or example how we can utilize Azure Stack. Let's say we have a special version of Stack Hub, which can be installed in an off-road vehicle. That Stack Hub vehicle, which is now equipped with a Stack hub, can act as a scout for emergencies. Let's say there's a disaster like earthquake, and you can then deploy this off-road vehicle to scout ahead for the rest of the emergency services. For example, this vehicle can map the roads and see where it is safe to drive ambulances or fire trucks. Like if we're transporting back wounded people, you don't want too many bumps. So we can map things like that. Or if like fire trucks are usually heavy, so if it's too damaged, they might not be able to get through. Or it can also map things like power lines, so that need to be repaired. So let's say we have this vehicle has drones, so that we can use the drones and map the extent of damage and also where the exact damage is and what type of damage it is, so that because we're getting live video feed, we can analyze, okay, here's a burnt wire, or here's a cut wire, or here's a tree that needs to be raised, pulled off from the wires and so on.
And this is where AI, edge, and computer vision can come into play and
Exactly.
get a smart analysis of the situation.
And this is just power, but think about lives. Like we can use these drones to pinpoint, okay, here's a building, we can analyze that we see people under rubble. So we can send people to a specific spot. Okay, there we need to have people raise, we need to remove the rubble. We will need ambulances there because they are going to be hurt in some way. Or if there's a fire somewhere, we can see, okay, what's the extent of a fire, and then we can send the fire trucks where it's the greatest need is. So together with a lot of technologies, Stack Hub or Stack Edge can help save lives in a disaster or in any other similar scenario. So let's talk about some scenarios which me and Linus has come up with. What can be interesting?
Yes, I'll start out with self-driving cars. So about 90% of road accidents are caused by human errors, and it results in a lot of unnecessary death, which has prompted several car companies to start to develop self-driving and autonomous cars because they have the potential of saving massive numbers of lives through safer driving, because they're not affected by fatigue, they're not affected by emotions, they're not affected by illness. They're always attentive, they always observe their environments, and they're always scanning in multiple directions. This is possible due to the existence of three different technologies. So IoT sensors, IoT connectivity, and software algorithms. So the sensors would include sensors, for example, for blind spot monitoring, forward collision warning, radar, camera, LiDAR, ultrasonic, all working together to make navigation of a self-driving car possible. And the IoT connectivity will allow the car to act upon traffic data, upon weather data, maps, nearby cars, locations of the cars, surface conditions, and help them monitor the surroundings and make better informed decisions in real time. So IoT edge computing can solve a lot of small computing tasks locally, but autonomous cars will still have to be connected to the cloud, though advances in IoT edge and AI edge technology will allow for more tasks to be solved locally and we get more and more powerful.
So here we have a quick, simple diagram of like we have a tons of sensors like front collision or weather, pressure, temperatures, road conditions, and so on. Even how somebody's driving. Even if like it doesn't have to be self-driving scenario, it can be a driver. So we can get a lot of data from there also, and then we can then push that through a IoT gateway to IoT Hub, from where we can process the data, save the data, and create reports. So once it's in Azure, we have a tremendous amount of possibilities to run to analyze the data on.
Yep. Agriculture. So this is another big one. As the world's population are growing, the demand for food will grow with it. By 2050, the global population is expected to exceed another few billion people. And modern agriculture will have to address this challenge, which will become even bigger because of global climate change. So not only will there be more people to feed, there might also be some areas we can no longer grow food, or we might have to change crops or whatever. And at the same time, the room for improvement within mechanization is rapidly decreasing as power-operated machines cannot get much bigger, heavier, or faster, which means that farming, in order to stay relevant, in order to feed all of us, will have to become smarter and move from mechanical optimization to a more data-driven agriculture, and basically towards precision farming, which is going to be a huge thing. And vital for this to work is that you have ruggedized systems designed for agriculture, so they can withstand the weather, humidity, rain, and whatnot. And they also have to be easy to use because most farmers do not have much experience with advanced IT.
Yeah.
If they can't use it, it won't make sense. Then it'll be a waste of
So
everything, basically.
usually when we create these solutions, we need to make them turnkey solutions. So they just put in,
Yeah,
maybe put in some sort of identity and then connect to the portal they have, this, the whole solution they have,
yeah,
and that's it.
exactly. And what's most important for most farmers is to increase their yield. And this can be attained by using IoT Edge devices because they can help reduce damage during planting, but also during harvesting. And they can also be used to assess a yield per square meter and the efficiency of, for example, fertilizers.
Yeah, so we have like sensors like which can who can sense nitrogen in the soil and other type of things that needs to be grown. Or the example you were talking about, Linus, before, just before, like they analyzed the pattern how they were feeding the cows, and just by timing it right, you can get
Yeah,
more yield. Like a cow can produce more milk.
that's an official Microsoft use case. It was a dairy farm, I think it was in Russia, and they found out that if they feed the cows when the weather is colder, the cow will produce more milk. And I think in this particular case, they grew the milk dairy production with 18% just by having IoT sensors monitoring the temperature in
Yeah,
the cow booths,
that's a huge increase, 18%.
which is a lot if you're
Yeah,
a dairy farmer.
yeah, exactly. So if we come back, we have like similar scenario with IoT. So you have your sensors, temperature, how the if there's a like it, we can even have sensors which can sense if there's a fire, there's a flood, and so on. If there's any seismic activity like earthquake,
Yeah.
and then we can take that all that data through the gateway again to Azure. But then we have second scenario where this needs to be disconnected because some of the farms are out there. They might not have a good internet connection. So they will need to have local processing. So if you remember the images I showed you, how we can deploy things on IoT Edge. So we have even we can even have IoT Hub on-prem in Edge scenario, and then we do all the insights we need. We can do on the ground, and then once we have the connectivity, we can push that data to cloud.
And another great thing with IoT Edge and the AI on the edge kind of coming together, uh, a huge problem in farming today is food waste.
Yeah,
So, for example, you grow a lot of food. Some of the potatoes you grow may not match the requirement for what they should look like in order to be sold in a supermarket. So you may harvest a bunch of stuff with your harvesting machines, bring them to the market. The market says, "Nah, we're not going to buy 20% of this. You have to bin it." Whereas if you have, say, computer vision monitoring your produce, you can immediately see like harvest there, don't harvest there, harvest there, harvest there, don't harvest there.
so
Uh,
instead of maybe sending that to the supermarket, we can send that to a chips factory, the
exactly,
potatoes who are not looking as good as, so that we as a consumer might not want to buy as a whole potato, but when we get a chip, it doesn't matter
exactly, or
because
to animal
it's
feed.
still edible.
Yeah, or to animal feed, or you can use it for fuel or whatever.
Yeah,
So this would be technology that could help decrease food waste, which is a big problem globally. And another one use case for IoT Edge is the predictive maintenance for machines, planting and harvesting machines, for example, because they're only used for a couple of weeks or months in a year. So they have to be reliable and they have to work perfectly during those times because otherwise you can't harvest or plant.
yeah. So just by one machine get, mm, let's say like your main machine, like main harvester breaks down, then you won't be able to harvest the whole season. the whole season spoiled for you. And as a farmer, you might actually go out of business because of one failure. So
Exactly.
there's like with IoT, we can address a lot of issues like sustainability, uh, economics, and so on. Then we have something which is more closer to Linus, museums.
Yeah, as a former archaeologist, I'm quite interested in stuff like this. So a lot of museums around the world, they would have collections of various types of artifacts. And some of them are very, very sensitive, very fragile, especially anything consisting of organic matter, such as human remains, or mummies, for example, textiles, manuscripts, painted artifacts, and so on. And they're very sensitive to humidity, they're very sensitive to light, they're very sensitive to the outbreath of visitors, for example, temperature, pressure. Yeah. So they're usually kept in protective glass cases. And they're often monitored, but often monitored individually. So you would have some sort of sensor, but they don't kind of come together for a 360 view of the whole collection, for example. And often the data is batch loaded, say once a week or once a month even. So if you're unlucky and you start to, have too much humidity, a mold starts to grow on that priceless manuscript you have, it may take you a month before you find it out, and that would be irreparable damage. And you
Let's
may find,
say there's a manuscript that needs total vacuum to survive
yeah,
today because
yeah,
it has degraded so much.
yeah,
It can be too late to save it if we don't manage the leaks in the system
yeah, yeah.
at
That
time.
has to be captured before the damage gets too bad. And it may sound like a small and trivial thing, but this is our shared human heritage. So these things do
Yeah.
matter. That's why they're in a museum to begin with.
And again, like it's a similar diagram how we will manage it. Like we can do a lot on-prem, we can do a lot in cloud, like immediate stuff, what's happening, leaks, change in humidity, change in temperature. We can address it at once with the device in Edge, and then we can do uh, more bulk, but still in real time calculations in the cloud.
An added bonus, if someone breaks in to steal the artifacts, we're gonna get some sort of alarm.
Yeah. So a lot of security system actually use IoT Edge and intelligent cloud together. Like they will have some sort of database of known, let's say, fugitives or known thieves, but then they will have an extended database on in cloud.
It's
And
very
then we have
interesting.
some case studies.
Yeah. We start with the Angkor Wat one.
Yeah.
So uh, in the past, archaeologists would typically, when they worked in the field to find new sites to dig, they would have to spend a lot of time hacking through dense jungle, machete in hand, trying to find that ancient ruin based on some old map they found somewhere. But nowadays, a lot of this can be done by using airborne laser scanning technology, or LiDAR. So it's possible to map a huge area in a fairly short while, which is changing how prospecting in archaeology is being done. And one example here is in Cambodia. And a team of archaeologists, they have discovered several medieval cities buried under the dense forest floor. And the largest one is said to be basically the same size as Phnom Penh, the capital of Cambodia. And it could potentially be new Angkor Wat, which is the famous Khmer capital. And at one time, it was actually the biggest city in the world with 1 million people, about 1,000 years ago. But this particular project ran between 2012 and 2015, and they had a LiDAR technology mounted on helicopters, and they mapped about 2,200 square kilometers with an accuracy of plus minus 150 millimeters. So with 16 data points, they managed to measure every square meter and to pinpoint well-known monumental stone structures in great detail, such as the remains of earthworks, mounds, canals, roads, and quarries. So not just like the buildings and the city themselves, but the surrounding support systems for the cities. And because of this, they have a fairly completely new understanding of, say, Khmer culture. But
Yeah.
this is applicable in similar locales in, say, the Mayas and Mexico. You would have several sub-Saharan cultures. Anywhere where you have dense growth and it's hard to see, where you previously had to use a machete, you can now use this technology. And
You were giving me example there again, Linus, about like how they eh, like found a lot of new cities in South America
Yeah, they have
by just
uncovered
using
some
drones.
yeah, so Mayan cities, and in Madagascar as well. So it's been a few locales around the world. But the main one I found was this one, and I
Yep.
used to work here, so I'm particularly interested in this area. But and another thing that can be used, you can combine this drone technology with AI on the edge, for
Mhm.
example. And then you can once again use computer vision, custom vision even to train what
Yep.
to look for. And then you can kind of screen out what's not so important to what is important. Because if you
So
have a lot of satellite images, a lot of images, you would have to have a big team of people spending a lot of time manually sifting
yeah.
through this. And AI would speed this up insanely.
So we have like we can train the AI to identify this is a tree, this is a building,
Yeah.
and it can disregard the tree, or if it's a certain type of tree that only grows in a certain area, so we can maybe look for this type of tree because that
Yeah.
means there's more likelihood of being a civilization there.
Yeah.
If
And if you have a locale where you really can't go, for example, you may not be able to fly, maybe military restrictions, commercial restrictions, or whatever, you can't send in drones, you could probably even take an Azure Stack, put it in a Jeep, drive it out, and just use that as a portable cloud. And then when you get back, you tank it up to the real cloud.
yeah, so we can so with a stack in a Jeep, we can actually do a lot of processing just at the site. All we need is power because everything else is built in.
Yeah, so a solar-powered mobile self-driving Azure Cloud driving around mapping the world.
Yep,
Yeah,
that
basically.
might not be that much of a what is that futuristic. It might be a possibility soon.
Yeah, we should totally pitch this. Azure
Uh,
Wheels coming soon.
yeah, and then we had another case where you were talking about like Tutankhamun's tomb.
Yeah, so the Valley of Kings in Egypt is probably one of the world's most important archaeological sites. It's been on a UNESCO World Heritage Site list since 1979. Uh, the valley is home to 765 rock-cut tombs, including the famous tomb of Tutankhamun. You can see his gold mask here. It's in the Egyptian Museum in Cairo at the moment, I think. And it was famously discovered by Howard Carter in 1922. And there was this famous curse: everyone who opens this tomb shall die, and people died mysteriously. So that kind of became a thing. But this valley is surrounded by limestone cliffs and sometimes experiences very heavy rains as well as the occasional earthquake. So
Yeah.
it's quite sensitive, and a lot of tourists as well,
Mm.
not to discount that fact. And with climate change, this is getting more and more extreme. So flooding is becoming more and more prevalent, and there is a real risk that the rock will basically just fall down and potentially crush someone or even destroy the locale or the tombs themselves.
And
Uh,
again, if you have like a lot of people in a room, it will change the characteristics of the room. It will
yeah,
change the temperature, the humidity, the
yeah,
pressure, even.
which is why they had to close down the famous Stone Age caves in southern France and Spain,
Yep.
Altamira and Lascaux, because there was destroying the paintings, just people breathing in the rooms. But what they've done here in the Valley of the Kings is that they set up a modified agriculture IoT system uh, with data being collected every 15 minutes, and then it's uploaded to a remote server over a cellular network. And then the data is used to provide early warning of potential damage, and then steps can be taken
Yep.
before anything happens to kind of take care of this, protect the site, and also protect the visitors.
And here we can see we have a bottleneck with the cellular network, like how fast it can provide us alerts. Like if we can deploy a intelligent edge solution there, then we will have much faster alert system.
Yeah. And also, this is not only applicable in the Valley of the Kings, with accelerating climate change as well as general wear and tear from many visitors. A lot of natural and man-made structures are in danger today and can benefit from IoT edge technology.
Mhm.
And thus, IoT
And
technology on the edge will be able to help and protect our heritage for future
precisely.
generations. Yeah.
And it's not even like so limited to man-made structures. Like there are some structures natural, like Colorado, the Grand Canyon.
Yeah.
So
Or glaciers. They're
glaciers, yeah,
melting up in the Himalayas, for example. You can monitor that, and you can predict when there's going to be floods or
or the ice
ice in
caps,
Antarctica. Yeah, ice
or
caps.
the like ice caps in the Antarctic.
Yeah,
So we can use this technology not just for preserving the old, but make sure that we can actually survive on this planet in future.
Yep. We may need this technology to be able to do that, to grow our foods,
Yep.
to take care of disaster, to navigate.
So, in summary, intelligent edge or IoT edge or in the AI at edge is more how we can get more rapid response to something than be, let's say, limited with the or restricted to because of the latency we have. And if anything else you want to put in, Linus?
I thought that was a fairly good conclusion. It's really bringing the benefits of the cloud to wherever the need is. And this is a big new thing because there has been a lot of parts of the world that hasn't been able to benefit from this kind of technology previously, especially in developing countries, for example. So in a way, this could be a democratization of technology.
Mm-hmm. And together with like the two new projects which were in the news last year, like for example, Project Natick, where they actually took a whole Azure data center and sunk it in the sea to test how it's going to behave, or the new container they have developed together with, I think, SpaceX or something.
Yeah.
So that can be deployed anywhere in the world as long as it has a power and satellite connection.
Yeah, and not only that, NASA is running their Artemis project, where they're going to land people on the moon and build a permanent moon base.
Yep.
And
So eventually we might have Azure on Moon.
yeah, we're working with SpaceX on that, so and they are the partners of NASA. Cool stuff.
So
Interesting
like,
times.
yeah. So IoT Edge is very exciting for the future, and we might be able to actually have IoT Edge soon on Mars. Because remember, if we take this scenario, like the latency between communication for the communication between Earth and Mars is a couple of hours.
Yeah.
And at best some minutes. Like if we have something that can take the decisions based on the input we have right there, that we might actually get further ahead in the research instead of like getting everything back to Earth, analyzing it, and then taking a decision where to move the robot, move the vehicles, the probes.
Yeah, and coming back to self-driving vehicles,
Yeah.
not also to mention if there ever is going to be a permanent base there, agriculture is going to have to benefit from this kind of technology.
So we will learn a lot from the technology. By using this technology, we will learn how the soil, the earth, how it actually behaves, so that we can replicate the scenario and monitor it in future on, let's say, Mars or Moon.
Yeah. So multiple use cases on planet, off planet, and anywhere in between.
Yeah.
And I think, correct me if I'm wrong, Ishan, but I have a feeling that there are new use cases popping up almost every day. Someone
Yeah.
is thinking about something new they can do with this that I never heard of
Absolutely.
before.
Absolutely. I mean, we are what, almost 7 billion people on the earth, so we will have a lot of ideas.
Yeah.
But not everybody might actually know about the technology.
Yeah, and that's the thing. And I think once they do and realize what they can do, they start coming up with it.
Yeah.
And I have a scenario with an energy company. Their experience is a rural municipality. And they're experiencing people stealing power from the grid to make moonshine. So they're using IoT Edge to monitor the power grid, so they will get an alert when this happens, so people stop stealing it for the moonshining machines. True case. I would
Yeah.
never have dreamed this up.
I have another customer who are actually taking the drone photos and analyzing which type of tree it is, which damage, if the tree has a damage, which type of damage. And the future is like if there is a forest fire, how much damage the tree had, and so on.
Yeah. And then you can probably get good indicators where to cut the fire paths to stop the spread, and where to put in the resources in
Yeah.
terms of putting it out.
And that's where the old like natural disaster scenario comes in. Like if whatever disaster it is, if we just have it, let's say a Jeep equipped with a stack, some couple of drones, we can do
Yeah.
a hell lot more by just being there with that equipment.
Yeah.
In
Things that wouldn't
like
have been able.
what we might be able to achieve in a month, we might be able to do it in a day. Then.
Yeah. And some of the things we can do today, we couldn't even dream of 10 years ago.
Yeah.
So it's speeding up. All right.
So what can you do? So we have a lot of architecture you can go through on Architecture Center, but I think where to start is actually maybe Microsoft Learn, which is on docs.microsoft.com/learn. There you have step-by-step guides, even labs. Microsoft is providing you with free labs, free resources to learn, and the Microsoft Learn also serves as a good base for if you're planning to take any certification, any of Microsoft certifications. And then we have Microsoft Docs, where everything is documented. And this is, even though we both work at Microsoft, this is our Bible.
Mm.
We don't have any internal secret documents. This is what we have. And
Yeah.
it is democratized. So you as a user can go to the docs.microsoft.com and you see any error, you click on edit, you edit it, send it for review. And then to start, you can always get a Azure free trial, which is a 30-day free trial. And you have 200 credits to consume.
Yeah. And another resource might be the Microsoft Virtual Training Days. They're free of charge. You can sign up for them. And then you typically get a voucher as well to take one of the fundamental exams, like Azure Data Fundamentals, AI Fundamentals, for example. So yeah, get started.
Yeah, get started. So that's all from us. Thank you. And we hope you will help us save our future with the help of IT Edge.
Thank you very much for listening, and all the best. Have a good day ahead.
Thank you.
Thanks.